Good morning. Today we're going to talk about taking some kind of function and then putting it into another function. So a good example of this is when you buy a shirt at the store. So let's say you're looking at these t-shirts and they're only $8 a piece, okay? So you're going to go and say, well, they are going to be 10% off. There's a sign that says 10% off the original price. So you do your calculations, you're going to take off 80 cents. All righty. So now your shirt is down to $7.20. Then you get to the register, and the person at the register says, hey, we're going to take off another 20% off of this shirt. So you're like, yeah, I'm really happy about this. So another 20% of $8 would be $1.60 off. So you're thinking, yeah, I can handle this. So you get there and it's like, you think you're going to be paying $5.60 for the shirt. But no, that doesn't happen that way. It's going to turn into something a little bit higher than that, because what they're going to do, most likely, is take it off of the sale price. So they're going to take 20% off. So instead of taking off $1.60, they're going to take off 20% of $7.20. Hold on, let me do this. 0.20 times 720. All right, they're going to only take off $1.44. Okay, so you're getting a little bit less of a discount than you thought you were going to be getting. And so then let's go see what we're going to end up with. Oops, I calculated this wrong. All right, $7.20 minus $1.44, and you're going to end up paying $5.76. All right, so you thought you're only going to pay $5.60. You end up paying $5.76. Here's what happened. They took 10% off the original price to get you there. Then they take 20% off the sale price. They don't go back to the original function. All right, so this is what we call a composition of functions. So it's also the process of putting one function into another function. Here is the notation. Take a minute and write that down, because this is basically saying we're going to start with the f function. We're going to put the g function inside of the f function. All right, so let's play around with that a little bit. All right, so you've got f of x is 4x plus 5, and g of x is 2x. So the first thing we're going to do, we're going to find, you got two problems here. You're going to find f of x and you're going to find g of x. All right, so I've got two problems here. So let's try f of g of x. Let's do this one first. So I like to think of these as boxes. So my f function is 4x plus 5. So you write down your 4x plus 5. I literally write it big too, because I like to have lots of room. All right, next, you're going to put the g function inside of the f function, but you're only going to put it in where the x is. So instead of writing 4x plus 5, all right, let me spread this out a little bit. All right, 4x plus 5, still writing it. I am going to take the entire g function and put it in for x here. So I'm going to erase this x and put in a 2x in its place. All right, just kind of take that for a minute and digest that. I have the entire f function going on here, and I took out the x, and I'm going to put the 2x in for the x. Then I'm just going to go and evaluate that. So now you just have to do order of operations. So that's why we've been practicing order of operations, so that we can get really good at it again. All right, so 4 times 2x is going to be 8x. This 4 does not go with the 5, so this just becomes 8x plus 5. So basically, f of g of x is equal to 8x plus 5. All right, so now let's go try it the other way around. Let's make g our original function, and then we're going to put f inside of it. So let me erase all this to get it out of the way. All right, so now we're going to try g of f of x. So our first function is our g function. It's on the outside. Think of it like a box, okay? You've got your big box and you've got your little box. Your big box is your g function, so you're going to write 2x. Now all of the f function is going to go inside of the g function. So this whole entire f function goes inside here. So it's going to go in for the x. So the f function goes in place of the x. So this becomes 4x plus 5. Okay? So think of it like that. If it helps to just do it like that and look at it like that, do that. Now we go and we distribute, because that 2 is going to go over everything. And we get 8x plus 10. That's not the same as f of g of x, right? So we've got g of f of x is equal to 8x. Ooh, I need two parentheses there. 8x plus 10. All right, so they are not commutative. So don't assume that if f of g of x, g of f of x is the same thing. They're very, ooh, I did not want to erase that. They are very different, okay? Very different. Let's try another one, all right? Oh, yeah, here's another way to write this. All right, you might see this little O looking in there, all right? It looks like the word fog. Sometimes it gets fun if you use the letter H, you got hog, all kinds of good stuff. Anyway, so this means f of g of x. It means the same thing, it's just a different notation. So some textbooks and some places will write it like that, but then some other places will just continue writing it like that. So this is the same thing, it's just different notation. So for example, the SOL will use this notation, but IXL and your math analysis book will use this notation. They're both the same, so just know that they mean the same thing. All right, so let's look at this next one. So you've got f of x equals x squared minus 9 and g of x equals x plus 4. All right, and we're just going to do f of g of x. I cannot see this. My brain does not know which function is the bigger function. When I look at it like that, I have to write it like this. That's just my brain, okay? And I've got to say, oh, my big function is f. Okay, so we're going to start with the f function. Our f function is x squared minus 9. So we're going to write, well, I'm going to start this out. F of g of x, just to remind myself, I'm going to start with my big function, x squared. I know I'm going to go and change that, minus 9. So it's basically like putting down a big box. Now you're going to put something inside of the big box. I'm going to put this little function, or, you know, it's not little, it's just what goes inside, okay? This is going to go in for the entire x. So this becomes x plus 4 all squared. Everything else stays exactly the same. All right, so instead of x, we're putting x plus 4 in there. Now we're going to go and do whatever it tells us to do. Now this is telling us to FOIL. So this really means x plus 4 times x plus 4 minus 9. All right, so we're going to FOIL that. So you got to do x times x, x squared, all of that, the outers and the inners. You get 4x and a 4x. And you get 4 times 4 is 16. And then don't forget, you got the negative 9 hanging off the end there. All right, now we just go and complete everything, and we combine our like terms like we did yesterday. You get x squared. This is going to be 8x because these two guys go together. And then you've got these two guys going together, and that's going to be a plus 7. So f of g of x is equal to x squared plus 8x plus 7. Don't have to do anything further with that. You could, you know, factor if you want. No big deal. Don't have to do it, though. You just really want the finished product. All right, I'm going to let you practice a couple of these on your own. So I've got two problems. I'm going to have them up on the board for you also. So you could copy these down right now. I'm not going to send them to you on Google Classroom as a separate file. This assignment and these two problems are your assignment for the day. So I'm just going to, it's right there on Google Classroom for you, but it's also going to be on the board for you. All right, and then turn this in today. This is due today. And I'll be walking around helping you. I hope this made sense. They're kind of fun if you like to calculate things. All right, have a good day.